All right, in this video, we're going to look at really three things. We're going to look at simplifying a rational expression, and then we're going to look at multiplying and dividing rational expressions. All right, so if we look here, we've got the rational expression 3x squared plus 27x plus 60 all over x cubed plus x squared minus 12x, and we're asked to simplify. So what we want to do anytime we're asked to simplify is we want to factor the numerator completely and the denominator completely. All right, so we'll start with that. And so if we look at the numerator, again, the first step in factoring is finding the greatest common factor. If it's anything other than 1, we need to factor it out. So if we look at 3x squared plus 27x plus 60, the greatest common factor there is 3. So I'm going to factor out a 3. Whoops. All right, so we factor out a 3. We got 3 times x squared plus 9x plus 20. All right, so again, we got just a little bit more work to do there with the trinomial x squared plus 9x plus 20, but we'll go ahead and start to look at the denominator. So the denominator x cubed plus x squared minus 12x, the greatest common factor there is x. So put the greatest common factor there, and so what we have in our parentheses would be x squared plus x minus 12. All right, so now we're going to turn our attention to the quadratic trinomials we have in both the numerator and denominator and factor those. And so we still have our GCF 3 there. Make my 2 parentheses for our 2 binomials. And so x squared plus 9x plus 20, the 2 factors will be x plus 4 and x plus 5. All right. The 4 times 5 will give you the positive 20, and 4 plus 5 will give us the coefficient 9 that we see in front of x. And so in the denominator, we have the GCF x still. Make our 2 parentheses for our 2 binomial factors. So when we factor x squared plus x minus 12, right, we know that negative 3 times positive 4 will give us negative 12, and if we add negative 3 plus 4, we'll get positive 1, which is the coefficient of the x term there. So one of these will be minus 3, and the other will have plus 4. All right, so we have factored completely. Now, once you have factored completely, and again, it's got to be factored in order to simplify when we're dealing with the rational expression. We're basically going to use the fact that if you take a non-zero number and divide it by itself, you get 1. Right? So when we have it in factored form, if you notice in the numerator, we have the factor x plus 4, and we have that same factor x plus 4 in the denominator. Right? And so when they're factors, we can just view that as x plus 4 divided by x plus 4, which would be 1. And so what we're going to do is mark those out because they divide together, divide out to be 1. It's not necessary to write down the multiple when it's 1. And so we mark out x plus 4 in the numerator and denominator, and again, that's what we'll do is we'll mark out any common factor between the numerator and denominator because they divide to be 1. Now, an important note is we can only do this with factors, right? We cannot mark out terms, right? We can't do the simplification in a rational expression between a term in the numerator and a term in the denominator, right? And again, terms, remember, are separated by addition and subtraction, whereas factors separated by multiplication. All right, so that's the only common factor that we have between the numerator and denominator, and so we just write down what's left, and that will be our simplified rational expression. So we have 3 times x plus 5 in our numerator, and you can leave it in factored form. If you want to distribute the 3 through the parentheses, you certainly can do that, and same thing in the denominator. If you want to distribute the x there, you can, but it's not required. And so that is in simplified form, so that would be our answer. Now, we're going to go to this next problem. Here, we're asked to multiply and simplify. Now, when we go to multiply two rational expressions, it just comes down to whether or not you can simplify a rational expression, right? Because when we multiply two fractions or two rational expressions together, we multiply straight across. We multiply numerators together, and then we multiply the denominators together, right? And so if we were to multiply and do that and get it as one rational expression, then we would try to simplify. And when we go to simplify, we're going to try to write it in factored form, right? So we're not actually going to necessarily perform the multiplication because if we did, we would then kind of undo that by trying to factor so that we could see if anything, will simplify. And so when we're asked to multiply two rational expressions, we're going to start the same way we just did when we were just trying to simplify. We're going to factor each numerator and each denominator as much as we can. All right, so if we look at this first rational expression, so the numerator x squared minus 5x plus 6, again, the greatest common factor here is a 1, so we'll try to factor the trinomial now, and so put my x here and my x here. The two integers that multiply to give us the positive 6, and we'll also add to give us the negative 5 in front of the x term, negative 3 and negative 2, right? Negative 3 times negative 2 is 6, and negative 3 plus negative 2 is the negative 5, the coefficient of x. So that's how that will factor. And so if we factor the denominator, again, the greatest common factor for x squared plus 7x minus 30 is also 1. And when we factor the trinomial, we're going to get one factor being x plus 10 and the other being x minus 3. 10 times negative 3 is the negative 30. 10 plus negative 3 is the positive 7. Now we'll move to the second rational expression. The numerator here, x squared minus 100. Greatest common factor is 1. This is a difference of squares. Right, x squared is obviously a square, and 100 is 10 squared. Right, so the first term is x squared, so we'll put x on the first spot. Again, 1 is going to have a plus, the other is going to have a minus, and 100 is 10 squared, so we'll put 10 here and 10 there. All right, and then the denominator, x squared plus 5x minus 14. GCF is 1, so factor the quadratic trinomial, so put x here and x here, which will give us the x squared. Two numbers that multiply to be negative 14, and we'll also add together to be positive 5 is positive 7 and negative 2. Now, when we go to multiply, we would multiply straight across, and so our numerator would be x minus 3 times x minus 2 times x plus 10 times x minus 10 over, and we'll multiply the denominators together, over x plus 10 times x minus 3 times x plus 7 times x minus 2, and then any factor that is both in the numerator and denominator would divide to be 1, and so we could mark those out. So if we want, we can go ahead and mark out in this step. So we can kind of go ahead and start simplifying in this step because, again, everything, what we have here between the two rational expressions is multiplication, right? So we can go ahead and do it in this step and it kind of save us a little bit of space. So the first factor in the numerator is x minus 3, and it is also a factor in the denominator, so they divide out to be 1, so I'm going to mark them out. All right, so if we move to the next factor, x minus 2 in the numerator, it is a factor in the second denominator, so again, they'll divide out to be 1, so we mark those out. All right, x plus 10 is a factor in both the numerator and the denominator, so we can mark those out. They divide out to be 1. And then the next factor in the numerator is x minus 10. It is not a factor in the denominator, so there's nothing we do to simplify that part of it. And so we've marked out each factor that occurred both in the numerator and denominator, and so now we write what's left. So in the numerator, what we have left is x minus 10, and in the denominator, we have the factor x plus 7. Right. And that's as simplified as we can get this. And again, as I said earlier, we cannot mark out terms, right? We have an x term in the numerator and an x term in the denominator. Here we cannot mark those out, right? It has to be factors. We can only mark out factors. All right, so this is our answer, x minus 10 over x plus 7. Now, when we go to look at division, there's just one added step to division that we didn't have to do in multiplication. It's the very first step, and it comes from really the definition of division that we really usually only apply when we're dealing with fractions, right? So I've got here how we are supposed to divide fractions. Now, at the beginning, I have that b cannot equal 0, d cannot equal 0, and c cannot equal 0, just so that to make sure that all of these fractions that we have within this statement are defined, right? And so if we're dividing a over b divided by c over d, right, the way that we need to rewrite that is we're going to keep the first term just as it is, the first fraction a over b. We're going to change the division and multiplication. We can do that by taking the reciprocal or flipping the second fraction. So where we had c over d here, when we converted it to multiplication, flip it, we get d over c. And then it's just a multiplication problem. All right, so that's going to be the first thing that we have to do when we're dividing rational expressions. All right, so if we look at one example here, so divide and simplify. Before I do anything else, what I'm going to do is I'm going to rewrite it as multiplication. All right, so I'm going to keep the first rational expression just as it is, 2x plus 8 over x squared minus 16. I'm going to change the division and multiplication. All right, and then we write down the reciprocal of the second rational expression, so x squared minus 8x plus 16 all over x plus 6. And now it's just a multiplication problem. So we're going to factor each numerator and denominator and then see if we can simplify. All right, so we'll go through and factor quickly. So 2x plus 8, the GCF is 2, so it's going to factor as 2 times x plus 4. X squared minus 16 is a difference of squares, so one factor is going to be x plus 4, the other will be x minus 4. We've got times. X squared minus 8x plus 16 factors as x plus 4 times x plus 4, which I would write out like that, especially when we're trying to see if anything will simplify. If you could write it as x plus 4 squared, but here I'm just going to write it as x plus 4 times x plus 4. Sorry, that should be x minus 4. Not paying attention. All right, so x minus 4 times x minus 4. All right, negative 4 times negative 4 gives us positive 16. Negative 4 plus negative 4 gives us the negative 8, the coefficient of x. And then x plus 6, there's nothing we can do to factor that. So now, see what we can do to simplify. So going through this, we have a factor of x plus 4 in this numerator. And we can only mark it out with, even though there's two, if there was more than one x plus 4 in the denominator, you could only mark it out with one, right? Not both. So here with the x plus 4, we mark it out with the x plus 4 there. And when we look at the x minus 4s, there's two factors of x minus 4 in the numerator, but only one in the denominator. So we can only mark out one of these in the numerator with that one in the denominator. Right, and so that's all that we could do to simplify. So our simplified answer, our numerator is 2 times x minus 4, which if you want to write as 2x minus 8, that's certainly fine. And then the denominator is x plus 6.